In this lecture, we are going to solve the second order linear differential equation with the constant coefficients of type 1 problems. Type 1 means the right hand side function is exponential function. So this is the second order linear differential equation with the constant coefficients. Suppose this q of x is e power ax, then it is fall under type 1. So for that, we first write the symbolic form of the differential equation and then find the auxiliary equation. The auxiliary equation is what? Auxiliary equation is a naught m square plus a1 m plus a2 equal to 0. Then solve this quadratic equation and then based on the roots, there are three classifications for writing the complementary function. And then the solution of the equation 1 is nothing but general solution is CF plus PI. So already we found CF. Now we will see how to find PI for type 1 problems. So PI equal to 1 divided by this in this equation, write the left hand side without y. So that is a naught d square plus a1 d plus a2 into the right hand side function, that is e power ax. And then replace d by a, which is the required particular solution, a naught a square plus a1a plus a2 into e power ax. This is the particular solution for type 1 problems, provided this should not be equal to 0. The denominator should not be equal to 0. Provided this denominator should not be equal to 0. Suppose the denominator is 0. Suppose the denominator is 0. In that case, then pi equal to, so multiply x in the numerator and differentiate the denominator, this one, with respect to d. Then what do we get? 2a naught d plus a1, because we are differentiating with respect to d into e power x. Now proceed like previous step, that is replace d by a, provided here also, provided 2a naught d means 2a naught a plus a1 should not be equal to 0. Suppose again we are getting 0. Suppose 2a naught a plus a1 is 0. Then once again you multiply x in the numerator, pi equal to, once again x should be multiplied in the numerator, and then once again differentiate the denominator with respect to d. That means you differentiate this one, that is 2a naught, that's all, into e power ax, which is your particular solution. Now we will solve problems based on this type. So problem is problem 1, solve d square minus 3d plus 2 of y equal to e power 3x. Solution. So first write the auxiliary equation. The auxiliary equation of this differential equation is m square minus 3m plus 2 equal to 0. So from this function of differential operator, you replace d by m, then you get the auxiliary equation. Now solve this equation by using quadratic formula or calculator or factorization. Any method you can use. Solve this equation. Then what you may get? M minus 1 into m minus 2 equal to 0. That means m equal to 1 comma 2. Since the roots of the quadratic equations are real and distinct, so CF is C1 e power m1x plus C2 e power m2x. That is C1 e power x, m1 is 1, so 1 into x plus C2 e power 2x. This is CF for this given problem. Now we need to find PI. PI equal to 1 divided by, write the left hand side of the given problem without y. That is d square minus 3d plus 2 into the right hand side of the given problem, e power 3x. Now replace d by 3. Now what do we get? 1 by 3 square minus 3 into 3 plus 2 into e power 3x. Now 3 into 3 square is 9 and 3 into 3 is 9. So this plus 9 and minus 9 get cancelled. Then e power 3x by 2 is the required PI for the given problem. We know general solution is complementary function plus particular integral, that is y equal to c1 e power x plus c2 e power 2x plus e power 3x by 2 is the required solution of the given problem. Now we will see the second problem. So second problem is d square y by dx square plus 2 dy by dx plus y equal to 1 minus e power x the whole square. Okay, so 1 minus e power x the whole square can be written as like a minus b the whole square. A minus b the whole square is what? A square minus 2ab plus b square. So you can expand it, then what you may get? 1 minus 2 e power x plus e power x the whole square, so that is e power 2x. Now if you write the symbolic form, then what you may get? D square y plus 2 dy plus y equal to 1 minus 2 e power x plus e power 2x. Similar, that is d square plus 2d plus y of y, sorry, plus 1 of y equal to 1 minus 2 e power x plus e power 2x. Now find CF. Before that, write the auxiliary equation. Auxiliary equation of this differential equation is nothing but m square plus 2m plus 1 equal to 0, which is nothing but m plus 1 the whole square equal to 0. That means m equal to minus 1 comma minus 1. So the roots are real and equal here. So for that case, CF is C1x plus C2 into e power mx, that is C1x plus C2 into e power minus x. This is the CF for this problem. Now we need to find PI. PI equal to 1 divided by, write the left hand side of the given equation without y. Means the function of operator you should write d square plus 2d plus 1 into, write the right hand side function 1 minus 2 e power x plus e power 2x. So which also can be written as 1 by d square plus 2d plus 1 into this 1 minus 1 by d square minus 2d plus 1 into e power 2 e power x plus 1 divided by d square minus 2d plus 1 e power 2x. Means you are taking this inside the bracket. So let it be pi1 minus pi2 plus pi3. Means you are taking this one as pi1 and this is as pi2 and finally this is pi3. Now solve one by one. So pi1 equal to 1 divided by d square plus 2d plus 1 into 1. 1 can be written as e power 0x. If some constant is there, suppose 5 is there, so 5 you can write as 5 e power 0x. So then this is of type 1. So in type 1 replace d by a, the coefficient of x in the exponential function. So now replace d by 0. Then what you may get? 1 divided by 0 square plus 2 into 0 plus 1 into e power 0x. So which is nothing but 0 square is 0, 2 into 0 is 0, then 0 plus 0 plus 1, so 1. So 1 into e power 0x, finally you may get 1 only. Similarly, find pi2. So pi2 equal to 1 divided by d square minus 2d plus 1 into 2 e power x. So now replace d by 1 because the coefficient of x is 1 in the exponential function. So what you may get? 1 divided by 1 square minus 2 into 1 plus 1 into 2 e power x. So what you may get in the denominator? Denominator is 1 minus 2 plus 1. So 0. If you are getting 0 in the denominator, in that case multiply x in the numerator and differentiate this denominator with respect to d. Then what you may get? 2d minus 2 into 2 e power x. Now again replace d by 1. Then what you may get? So which is equal to x by 2 into 1 minus 2 into 2 e power x. So once again you are getting 0 again in the denominator. Then once again you multiply x in the numerator. Already one x is there. So you get x square by differentiate this denominator with respect to d. Then what you may get? 2 into 2 e power x. So this 2 and 2 get cancelled. Then you get simply x square e power x. Now find pi3. So pi3 is this one. Now find pi3. Then what do we get? pi3 equal to this one. Now which is equal to, now replace d by 2. Then what do we get? 1 by 2 square minus 2 into 2 plus 1 e power 2x. Then 2 square is 4 and 2 into 2 is 4. Plus 4 minus 4 get cancelled. Then simply you get e power 2x. So pi is nothing but pi1 minus pi2 plus pi3. So pi1 is what? pi1 is simply 1. 1 minus pi2 is x square e power x plus pi3 is e power 2x. So general solution is what? Cf plus pi. So you will get what is your Cf? Cf is c1x plus c2 into e power minus x. This is your Cf. So Cf plus pi, c1x plus c2 into e power minus x plus pi is 1 minus x square e power x plus e power 2x. Now consider the next problem. Problem number 3 is d square minus 2d plus 1 of y equal to sine h3x. So this is a hyperbolic function sine h3x. Sin sin Hax can be written as e power ax minus e power minus ax by 2. Similarly, cos Hax can be written as e power ax plus e power minus ax by 2. So sin h3x can be written as, here a is 3, so e power 3x minus e power minus 3x by 2. So once again, this is of type 1 only because exponential function. So that is e power 3x by 2 minus e power minus 3x by 2. So like you can consider this as pi1 and pi2. So like previous problem, if you solve, then you get the required solution. Thank you.